Welcome to week 4. This week, the primary focus of class is going to be on the methods exam, and so working through questions that you have as a group, and then obviously responding to them individually for the particular studies that you've been assigned. But in addition to that, to keep the discussion moving forward, the readings are going to focus on quantitative inquiry, and this is really where we're going with the remainder of the class. And so what I wanted to do with the lecture today is just provide you with a quick overview of quantitative inquiry. And so I'm going to hit on several topics. And so starting with a scale that you're familiar with, because in week 1 I had you take the anthropocentric biocentric scale that's been developed by Jerry Vasky at Colorado State. And we're going to use that as an example to go ahead and talk about why attitudinal scales are important to measure latent constructs. We'll talk about data entry, descriptive statistics, reverse coding, and factor analysis. And because I'm preparing this lecture before the semester began, this is actually last year's data, but again, a data set that at least the questions you should be familiar with from week 1. So we'll go ahead and get started on that. If you recall, back in week 1, I had you go ahead and answer this short survey, and we'll have discussed parts of this during that first week of class, but I wanted to return to this as an example. And so we spend a lot of time in this class talking about measuring latent constructs, and this scale is a good example of this. So this was a scale developed by Jerry Vasky at Colorado State, and Jerry's primary area of interest from a research perspective is understanding people's value orientations towards the forest and how that influences their behaviors and attitudes towards management of national forest land. And so what Jerry developed in this particular scale, which he published in 1999, is really a continuum. And he was trying to place people somewhere. He understood that people fall somewhere on a line between a biocentric perspective on the forest, which would, to use one of the statements to sum up what that means, is that forests have value regardless of people being present, so focused on the natural systems and the importance of those natural systems, to an anthropocentric opposite end of that same spectrum, or that continuum, which would be that the primary value of forests is to provide resources such as timber and minerals for people who depend on them for their way of life. And again, this particular scale was set up in a way that allows, the individual questions are helping assign each respondent to somewhere on that continuum. And so even though you see the pattern here that the biocentric statements are represented in the odd statements, so 1, 3, 5, etc., and the anthropocentric statements are represented in 2, 4, 6, 8, etc., right? That's the way that the scale was set up and the way I presented it to you when you took the survey earlier in the semester. And so, again, this is just a good example. We'll go ahead and build off of this for the rest of this lecture just to discuss the basic process of quantitative inquiry. All right, you get some of this in the tutorials for this class, but I just wanted to show you quickly how this data laid into SPSS. And so obviously we're taking a look at the data view right now. There's also the variable view tab, which is where you set up each one of these columns. And you look here at the data entry, or the data view side of things, and you'll see that each respondent has their own classification. Just for simple data entry here, it's just their initials. And then the way that I went about entering this is that, on the previous slide and when you took the survey, you saw that you had a range of 5 options, from strongly disagree to strongly agree with a neutral category in the middle. And so as I entered this data, what you'll see here is that I represented that using a positive and negative continuum. And so, meaning that if someone answered strongly disagree, it's a -2, and if somebody answered strongly agree to a question, I entered it in as strongly agree. And so basically, and that's the simple version of how we would start to input data for a study. Again, you probably got some of this, I hope you got some of this out of the SPSS tutorials that you've done in previous weeks. But I just, again, what would you do? What's the first thing you do once you have the data entered? And to be honest, the simplest and easiest thing we do is we immediately go to descriptive statistics. We want to understand what our data set looks like, understand if there are issues that need to be corrected before we attempt anything more complex. For some of you, it depends on the project or the thesis that you're working on. Maybe descriptive statistics is appropriate for the type of work that you're doing, and this is really where you would spend a lot of your time focused on. For others, you're going to start looking at relationship testing and understanding the relationships between variables, and descriptive statistics is really just a first stopping point on the quantitative analysis spectrum. And so what you'll see here is that, with number 1 that I've labeled out here, you can actually pull up your frequencies through the SPSS analysis tab. And you'll see that all I did was I took all of the items, and so items 1 through 10, and I've moved them over into the variables. And then I hit the statistics tab at the top right of that window, which brings up box number 2. And in that, you can actually specify out which of the descriptive statistics you'd like. And so you can do minimum, maximum, standard deviation range. There's others. You can also specify your central tendency, so mean would be the most common, but there may be a reason to use median or mode as well. One other feature that going back to box number 1 that is always good to go ahead and check into is go ahead and hit charts, which brings up box number 3. And what I've chosen to do in this case is to develop a histogram, and included that as well. One thing I will say about SPSS, and just as food for thought as you kind of go about doing your work, SPSS does a pretty good job of bringing a lot of statistical tools together in one place, but the graphics are not high quality. I tend to do my graphic work in a different software program, even if it means exporting my data from SPSS into Excel in order to develop better graphics in that environment. I know some people do things differently, but SPSS tends not to be the best place for that. And so that's just something to keep in mind as you kind of move into your own work. All right. You may have noticed in the data entry slide that last semester we only had 7 people in this class, so it was a pretty small group. And so what you'll see here is I have 7 valid responses for all 10 questions, and so that's an important thing to look. That'd be one of the first places to check is how many valid responses and how many missing responses do you have in your data set. And then the other thing you can start looking at here is you can actually start to see some of the trends within your data and look at which questions are most interesting. One of the things that, a red flag that jumps out for me immediately in this particular data set that's here on the screen is the very first column. So forests have value regardless of people being present. Well, again, I asked this of environmental education and human dimensions students, and not surprisingly, I suppose, they came back and all of them answered strongly agree to this question. All 7 responses are strongly agree. And so what you see here is you see no variation in this data set. And so if the point of quantitative inquiry is to try and start to separate people out or understand differences amongst people, this wouldn't do a very good job of starting to identify differences. But there are other instances where quantitative inquiry, the purpose is to understand levels of support or understand people's attitudes towards a new policy or project. And to be honest, from a descriptive statistics standpoint, if everybody agrees that what you're doing is wonderful, maybe that's a really useful thing as well. The other thing I've included in here is I've actually gone ahead and pulled up the histogram for one of the ones that I actually think is more interesting, which is the second column and the responses. And we do see more variation there, and we actually see responses ranging from strongly disagree to agree on this one. And you'll see that we don't have a normal distribution. A lot of that's a function of a very, very small sample size in this case. But this starts to give you the understanding of here's something where we're actually seeing differences. Maybe this is something to flag to come back and do some further analysis on. With this slide, I just wanted to point out, make it really obvious that the way that I presented this scale to you, I set it up as alternating questions between biocentric, which are marked here in the red B's, and anthropocentric question, which are marked in the white gray A's. And I did this on purpose as to, you may have felt like you were kind of bouncing back and forth between extremes as you were responding to this question. But that's the way I chose to go ahead and lay this out for you. In a lot of cases, that makes a lot of sense to kind of lay it out so you're kind of bouncing people back and forth a little bit. There may be reasons to put all 5 questions blocked together and then the other 5 questions blocked together separately. By intertwining them like this, I think in the way that, discussions I've had with other people who do this work is that this tends to allow the respondent to understand that you're asking these as a cohesive unit rather than as a separate series of questions. But again, the rationale for how you choose to do this is one of those things that takes time and pre-testing to figure out if respondents are actually accurately answering the questions, or if a pattern like this is really bothers the people you pre-test it with, then there's reason to change it. And so, anyway, I just wanted to point that out before I move on to reverse coding. So reverse coding is just a simple process whereby we take responses to an individual survey item and we flip the coding, meaning that we take a strongly agree statement or a strongly agree response and we turn it into a strongly disagree response. And the coding would be the same for all of them. So we would actually reverse the positive and negative aspects of responses to that item. Now, why in the world would we ever want to do that? Well, one of the things that we've been reading about in this course is that including positive and negative statements within a scale is really important so that people's feel like their views have been represented. The example, so Vasky's scale here, the forest values continuum, is really asking questions about a biocentric view and anthropocentric views. And so, but if the goal is to use these 10 items to come up with an individual score measuring biocentric value orientation towards the forest, then what would need to happen with the anthropocentric items is that we'd need to reverse code those, because the assumption in that scale is that biocentric and anthropocentric are two opposite ends of the same spectrum. And so by reverse coding the anthropocentric items, you force them to align, those responses to align with the biocentric items. And so in practice, what that means is that that you would anticipate somebody who strongly agrees with a biocentric item to also strongly disagree with an anthropocentric item. By taking the anthropocentric items and reverse coding those, you bring those into alignment so that all statements are positive evaluations of the biocentric view of the forest. And so that's the purpose. And so here's a quick screenshot of how you do this in SPSS, and it's set up where you see -2 goes to +2. So the old value is -2, so strongly disagree. The new value is +2, so it's strongly agree. So that's the process for reverse coding. Following up on reverse coding is, again, it seems like something that it's wrong to take and flip people's responses around. So why would we do this? Well, if the ultimate point of the scale is to come up with one value, so here at the bottom of the slide, if it's to come up with a biocentric orientation rating, so a numerical value representing each respondent's biocentric orientation, then it's necessary to align those statements to be in support of a biocentric world, orientation. And so one of the reasons we do that is the next step in this scale analysis process is it requires us to actually use factor analysis. And so what is factor analysis? This is a big question, and we have some readings about this, and I'm not going to get all of the nuances of factor analysis included in this one slide. I'd be talking for the next hour, and you don't want that. And I probably still wouldn't get it all done. But what factor analysis allows us to do is it allows us to take the items, and in this case what I've included is I've included the biocentric items and then the reverse-coded anthropocentric items. So all 10 items are represented here. And I've included them in a factor analysis. I've used a rotated solution, which is just something that's more than what we're talking about at the moment. But what this does is that here in column 1, under component 1, it'll actually give us an analysis of the correlation or covariance between these different items so that we can identify items that are actually likely to be measuring the same underlying latent construct. And so that's an oversimplification of what factor analysis is, but I think it's a good starting point for the discussion. And so what you'll see in here is you'll see items that are strongly correlated to one another. In column 1, you'll see that I feel that I'm part of the natural world that includes plant, animal, and marine systems. It's, has a 0.628 loading on that factor. If you see the second item, it also has fairly strong, above 0.4, tends to be fairly strong loadings. And then we go down to the reverse coding items, and we see the items, reverse coded items 2, 4, and 6 all also are really strongly loading on this item. And so what that tells me is I can go ahead and pull those 5 items out and I can create a summated scale. So I can add the responses to those 5 items out for every person who responded to the survey, and I can come up with this biocentric orientation rating. And so this is where all of this process, starts to lead to. And again, what's the purpose of having this rating scale, or bringing some numerical value to an overall scale, is that if we're going to start investigating relationships, the statistics required to do that through correlation analysis or regression analysis absolutely force us to have some numerical value representing that latent construct. It's really important. The other thing that's really useful about it, just from a descriptive statistics standpoint, is that rather than having patterns of responses across, for 10 different items and trying to make sense of that, we can now have one score, and then we can see where people scored most closely together. We might even be able to run something like a cluster analysis that would allow us to figure out which groups of people responded in a similar way, share a similar value orientation towards the forest. And so I'm going to go ahead and stop at this point. We'll go back into the readings and onto the discussion boards for the week. But hopefully this gives you kind of an understanding of how we're starting to add some layers of complexity into doing quantitative inquiry.